In this video, we will be having a rundown. Uh, Basically, go through a particular Anki deck that I created a few months back. This is in preparation for DCAT. The Basically, what DCAT stands for is the De La Salle College Admission Test. So, yeah, what we have right here, basically these are cards, flashcards, basically, and yeah, we'll go through each one. So first, by the way, this is science. There are multiple subjects in the DCAT. One of them is science. So yeah, general science. So let's start with this first flashcard. So blank is a device for measuring blank. It does so by measuring the temperature difference between a dry thermometer bulb and a wet thermometer bulb that has lost some moisture due to evaporation. This is a psychrometer. So it is used to measure air humidity. So keywords: psychrometer, air humidity. So yeah, the following sentence is just a supporting detail, but what's most important to know is that a psychrometer is to measure air humidity. Next, the blank effect is the process through which blank is blank near Earth's surface by substances known as. Okay, one thing that I could improve on in these flashcards is basically just place one blank. I think it wouldn't make sense if you have to look for multiple blanks. Anyways, this is the greenhouse effect. So this is a process through which heat is trapped near Earth's surface by substances known as greenhouse gases. So this is, I believe, affiliated with the idea of global warming. More greenhouse gases, the warmer the Earth is, basically. Key phrase, basically, heat is trapped near Earth's surface. I think this has to be in the atmosphere. So imagine these gases as a cozy blanket enveloping our planet, helping to maintain a warmer temperature than it would have otherwise. Okay? Next, this is a sphygmomanometer. Anyways, this is used to measure blood pressure. Sphygmomanometer. Okay. So, it's in other words called a blood pressure monitor or a blood pressure gauge. So yeah, it's self-explanatory. It's for measuring blood pressure. Next. So, scientific method. Here, after developing something, we test the what? Hypothesis or prediction. So the first method, the first step is to make an observation. I think it's synonymous with synthesizing a hypothesis. And we, of course, ask a question. That's going to be the main question that we intend to answer in investigating basically, in a research paper, we have a particular question that we need to ask. And the answer for that, in order to get that answer, we employ specific scientific methods in order to achieve that. So, yeah. Then, for the third step, we develop a hypothesis or prediction and we test it. That's the fourth step. Fifth step is basically to analyze the results that we get. And sixth, we record the results against our hypothesis, and from there, we make a conclusion. Do we accept or reject the hypothesis? Okay. Next, Doppler effect is the blank in the blank in relation to an observer due to relative motion of the wave source and observer. I think one example for Doppler effect is as police cars pass by. Imagine you're walking along a sidewalk and suddenly a police car or an ambulance, regardless of the vehicle, as long as there is a siren. So as it moves closer to you and eventually farther from you, so there you can witness a shift in the frequency of a wave. So I think that's basically it. Higher pitch when you're closer to the siren, to the sound. There is lower pitch when you're farther from that sound. And about light, actually I'm not sure about this example, but for sound, I've already explained it. Okay, so let's talk about the layers of the atmosphere. The lowest layer is the troposphere. I think this is where buildings are seen. I don't think there has been any building that has reached higher than the troposphere. I think the stratosphere, which is the next layer after the troposphere, I think this is where airplanes are visible. I think I can't be sure. It's been quite some time since I've recalled this information. But for the mesosphere, that's the next after strato. This is where shooting stars blaze. One of these layers is known for being the coldest. I believe it's the mesosphere. And what's the hottest is the one next to it. That is the thermosphere. Thermosphere is the hottest. This is the layer where a lot of heat coming from the sun is trapped. So yeah, as you can see, it says the temperature of the thermosphere is 230 degrees Celsius. And in the exosphere, that's basically the farthest layer of the atmosphere. So I believe there is no longer any oxygen here. It's basically inner space. And after that, after the exosphere, I believe it's already outer space. Okay? Yeah. I almost forgot to mention. In the troposphere, this is where weather is evident. This is where weather forms. The stratosphere is where the ozone layer is located at. Okay? I think that's all. Next, analyze results. Okay? So, I think this is geohistory. Mesozoic era. Under this, we have the Cretaceous, Jurassic, and Triassic. I think everything here in this category is classified as period. The ones written here vertically, they're classified as eras, I think. These ones, I don't know, Archean something, Proterozoic something. There's definitely something for that. But Paleozoic, it's usually synonymous with old. So yeah, periods under the Paleozoic era are as seen here. Mesozoic, I've already mentioned that. The closest to our present time is the Cenozoic. So Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene, and Holocene. Holocene is I believe where we are right now. So since 10,000 years ago, we've already been in the Holocene era. So that's it. Earth has formed 4.6 billion years ago. After its formation came forth the Archean. Okay. This is Cenozoic. Okay. Sphygmomanometer. What is this? Okay. We have basically three types of rock. This is earth science. Igneous, metamorphic, and sedimentary. So, for sedimentary rock, this basically is the rock cycle, this entire flow chart. So as you can see in this right side, let's start here first. So magma, when it cools, it eventually becomes igneous rock. When it melts, it forms back into magma. It turns back into magma, basically. When igneous rock experiences weathering and erosion, when it is subjected to weathering, it turns into sediment, and all of the accumulated sediment experiences compacting and cementing, and it would eventually be sedimentary rocks. They would eventually be sedimentary rocks. Bigger forms, basically. Because again, they are being cemented. So, after being sedimentary rocks, if they get subjected to immense heat and pressure, they become metamorphic. And when metamorphic rocks melt, they turn back into magma. Magma, when it cools, it becomes igneous rocks again. So that's all for the outer cycle. How about the inner part? So coming from igneous rocks, if they are subject immediately to immense heat and pressure, they don't have to go through being sedimentary rocks. Just with heat and pressure, they become metamorphic. Coming from here, being a metamorphic rock, when you get subjected to weathering and erosion, you become sediments. Same goes when you come from being an igneous rock. That's basically it. And of course, when weathering and erosion occurs in sedimentary rocks, they turn back into sediments. So basically, they break down. Okay? Blank are instruments used to record the motion of the ground during an earthquake. I think this machine has a pen. Okay, I actually don't know what it is. Let's see the answer. Seismograph. Yeah, I knew it. The seismograph is basically, it has a pen. It writes down a drawing similar to a heartbeat. Well, not so similar to a heartbeat, but basically, if the writing, let me just demonstrate it to you. Well, I can't use my Wi-Fi, my internet right now. I have something that's personal, so unless I edit this video, which I won't, we'll just keep going. But basically, seismographs are used to measure the motion, I guess. Better word is record, not motion. Not measure. But yeah, the stronger the earthquake is, you can see in the reading of a seismograph that the drawing extends in a certain paper. Imagine the electromagnetic spectrum. The portion with the highest frequency, that's usually what you see in a seismograph reading. And the more intense the, like what I said, if the drawing is extremely intense, then yeah, basically the earthquake is strong. Next. So this is the Earth's atmosphere. So yeah, back to what we discussed again. This is the mesosphere. This is the this is the ozone layer. Stratosphere. Technically, the ozone is still part of the stratosphere. The troposphere is closest to Earth's surface, like as in ground. Tropopause, stratopause, mesopause. Kármán line is located within the thermosphere. We have the exosphere over here, and the exterior space. Okay, we've been there already. Relative motion. Okay, anatomy of an earthquake. What do you call this? I believe this is not the epicenter. Seismic waves. Okay, so they are waves that transmit the energy released by an earthquake. This is called a fault. This is a fracture in the rocks that make up the Earth's crust. This is the epicenter. It's basically the location above the focus. The focus, on the other hand, is the point within the Earth where an earthquake rupture starts. And we have the plates. They are massive rocks that make up the outer layer of the Earth's surface and whose movement along the faults triggers earthquakes. So that's basically it. Okay, we've been there already. A phenomenon by which the Coriolis, am I right? Colloidal particles scatter light. Okay, so sorry. We'll get back to that later. I accidentally pressed the space bar. Measures wind and wind pressure. What instrument is this? It's not the same instrument as the one that was mentioned earlier. This is an anemometer. Okay. I believe this is used to measure the wind speed of a typhoon. I may be wrong on that regard, but it's basically a mere idea that I thought of, like, because it does measure wind speed, so it might be associated with typhoons, right? Next, okay, the sphygmomanometer. Okay, so because the Earth rotates on its axis, the circulating air is deflected toward the blank in the blank. This is either northern or southern hemisphere. I think this is the Coriolis effect. Yeah, Coriolis. So towards the right in the northern hemisphere, and towards the left in the southern hemisphere. So we're talking about circulating air. This could be better visualized with a picture. Not sure why I didn't add one. Anyways. In the scientific method, an intelligent or educated guess that serves as a tentative answer or solution to a problem. So tentative means not permanent. It's temporary. I think this is a hypothesis A. That is correct. Troposphere. Okay. Ozone layer. There you go. Coriolis effect. Towards the right in the northern hemisphere. Towards the left in the southern hemisphere. Doppler effect is the blank in the frequency of a wave in relation to an observer due to relative motion. Exterior space. Something line. Karman. Okay. This is a fault. Ionosphere, or in other words, thermosphere, I believe. The blank effect is the process to which blank is blank near Earth's surface. Okay, heat is trapped, known as greenhouse gases. I think this is a Tyndall. No, greenhouse effect. So from the word from the phrase greenhouse gases, it's a greenhouse effect. Towards the left in the southern hemisphere. Towards okay. I think this is already repetitive. Let's just keep going. Point at the surface of the earth above the focus. The red one, look at the red. The point within the earth where an earthquake rupture starts. Directly above. Okay. I think this is a new flashcard. A barometer is a scientific instrument that is used to measure air pressure in a certain environment. Okay. Anemometer. Wind speed and wind pressure. Okay. Sphygmomanometer. Test the results. Prediction. This one is not the Archean. It's the one after the Archean, Proterozoic. Okay. Strato something. Stratopause. Archean. Where the ozone layer floats. Plates. Mesopause. Develop a hypothesis or prediction. Exopause. Just kidding. Thermopause. Which of the following is an example of an igneous rock? Granite. Everything else, well, limestone is, I think this is associated with being organic. It's granite. There you go. Okay. Common types of igneous rocks, we have granite and obsidian. For sedimentary rocks, we have sandstone, limestone, and coal. For metamorphic rocks, we have slate and marble. And there are subtypes for each type of rock. For igneous, we have intrusive types. They cooled slowly. For extrusive igneous rocks, let me think. Okay, I remember. So for igneous intrusive, basically the cooling, they finished cooling, like the crystallization process, has been completed while they are inside the Earth's surface. For extrusive, from the word rapid, so they cooled really fast because they finished their crystallization process above the Earth's surface. So naturally, Earth's surface is colder than, let's say, a volcano's inside, right? So, okay, let's move on to sedimentary. Clastic, compacted broken rocks. Chemical, compacted dissolved minerals. So, yeah, like what I said earlier, for limestone, it's associated with, well, there is something wrong from what I said earlier. Limestone cannot be confused with being classified as organic type. Organic is a different story. This is compacted biogenic matter. One example is coal, a non-renewable energy resource. For metamorphic, we have foliated and non-foliated. For foliated types, they have layers. For non-foliated types, of course, from the word non, they have no layers. Okay. Air humidity. What is used to measure air humidity? I believe this is the first instrument that was mentioned. Psychrometer. Greenhouse gases. Barometer to measure air pressure. Phenomenon by which the blank colloidal particles. I don't know why this cannot be under. Ah yes, Tyndall effect. It's already here. Okay, I think that's all for this Anki deck. Thanks for watching.